Hello everyone and welcome back to ZipZap Academy, and today we are going to learn about friction. Today we are going to see what is the definition of friction, what are the types of friction, and how can we calculate friction, and some questions also. So let's see. You might have studied friction as the force which opposes motion. So imagine this is a surface, this is a rough surface, and the body is moving with some acceleration A. So there's going to be a force which will oppose this motion known as friction. So friction can be calculated as F, or friction, is equal to mu n. I'm going to tell you what is this equation. Just remember this. Okay. So there are basically three types of friction. One is static friction. Okay. One is static friction. The next is kinetic friction, and the third one is rolling friction. Okay, so let's see what is static friction. When a body is on a surface but the body is at rest, the acceleration is zero. It's at rest. Therefore there is some friction which is keeping the body at rest. There is some friction, we know that. So this friction is known as static friction. This friction is known as static friction. When a body is at rest, the friction produced between the body and the surface is static friction. Now if I put a person over here and tell him to apply a force of, let's say, 3 newtons, okay, the body would not move. Okay, the person is applying a force of 3 newton, but the body is not moving. This means that the static friction value is higher than 3 newton. The value of the static friction is higher than 3 newton. Therefore the body is not able to move. If this person applies a force of, let's say, 10 newton, then this object just gets ready to move. This statement means that when the person is applying the force of 10 newton, the body just starts to move. Like, it will just move very slightly. It will, like, just start to move. It will be ready to move. Like, there is yellow light, like, the traffic signals. There's red light, yellow light, and green light. Green means go, and red means stop, but the yellow means be ready to stop. Okay, so this means that the body will just be ready to go. And this value where the body just starts or will be ready to go is known as limiting friction. Now let's see what is kinetic friction. When a body is moving, okay, now the body is moving with some acceleration. Let's take 5 meter per second square. So there's going to be some opposition of force. This force is going to be kinetic friction. This doesn't need any further explanation. It's clear. When a body is moving, the type of friction is kinetic friction. When the body is at rest, the type of friction is static friction. Now let's see rolling friction. Now let's see. You might have seen the tires of a car. Let's see. For example, this is the tire of a car. Okay, and this is rolling. You understand? This is not sliding. Okay, kinetic friction is also known as sliding friction. Okay, is when a body rolls over the surface. That means this point will get rolled over and come to this point again, whereas in a sliding friction this point will remain constant. Sliding friction, the point will remain constant. This will just slide, whereas in this is going to come take a complete 360 revolution and come back over it. Now let me ask you a question. The value of which friction is going to be higher? Static friction, kinetic friction, or rolling friction? Now, the value of static friction is going to be higher because friction is caused due to irregularities in the surface and in the body. You know that. So, example, these are the irregularities in the surface, and these are the irregularities in the object. So, when these irregularities meet or when these intersect, friction is created. Now, in the case of rolling friction, you can see that the now you can see that in rolling friction the surface in contact is very less, whereas in sliding friction the surface of contact is very much. So the value of rolling friction would be very less, whereas the value of sliding friction whereas the value of static friction is going to be higher. And kinetic friction depends upon the shape of the object, or so we can derive something like that. The value of static friction is higher than value of kinetic friction is higher than value of rolling friction. So the value of rolling friction is the least, whereas the value of static friction is the most. Now let's see at the formula of friction. So friction is to be given as f, small f is defined as mu n, where mu is the coefficient of friction, okay, coefficient of friction, and n is the normal force, okay. Now what is coefficient of friction? So coefficient of friction is different for each surface. So it depends on the number of irregularities. If the surface is very rough, that means it has many irregularities, then the coefficient of friction will be very high. Okay, then the coefficient of friction will be very high. But if there is less irregularities and the surface is smooth, like very less irregularities, then the coefficient of friction for this will be very low. Understood? So coefficient of friction is of constant value for every surface, and normal reaction, I'm going to tell you what it is. So let's see. So for example, this is a body of mass m. So what its weight going to be? Weight is equal to mg. You all know that weight is equal to mg. So the force downwards is going to be mg, and the normal force is the opposite force. Now Newton's third law says every action has an equal and opposite reaction. So the force mg would also have an equal and opposite reaction. So similarly, there's a force which is equal and opposite. This force is the normal force. So normal is nothing but equal to mg, but it is equal but opposite. So n can be written as mg. Understood? And n is always a perpendicular force. It is always perpendicular to the surface. Now let's see, if there is an inclined surface, for example this is an inclined surface at some theta angle, and there's a body kept, so what's going to be the normal force at this stage? So we know that mg always acts downwards, so here will be mg. But we also know that normal is a perpendicular force. So here normal would act like this, which is perpendicular to the surface. So how can we evaluate mg with normal here? We cannot evaluate mg with normal here. In this case, we will resolve the vectors. So for resolving the mg vector, we would have to multiply it with cos theta. We all know, because in ax is equal to a cos theta and ay is equal to a sin theta. Okay, so on the x axis it's a cos theta and on the y axis it's a sin theta. So here it is the x-axis. We're going to take this as y and this is x. So on the x-axis it will become a cos theta. So this becomes n is equal to mg cos theta. Simple. So in this case normal would become mg cos theta. Now let's see at the first question. There's a surface, a rough surface, which has a coefficient of friction of 0.5, and there's a body which has mass of 5 kg. Find the friction produced, find the static friction produced. Okay, we have to find static friction. Now let's see. Okay, so we know that normal is equal to mass into gravity. So here we can take the gravity as 10 meter per second square. So if we take the gravity as 10, then the weight on the normal would become 50 Newton, and the mu would remain the same, 0.5. So the in turn the friction would become 50 into 0.5, which is 25 Newton. So we got the friction as 25 Newton. Now let's take a difficult example, like a bit confusing. Okay. So the question is, a book is of a weight 20 Newton. So for example, this is a book which has a weight of 20 Newton and pressed by two hands, which is pressed by two hands. So these are the two hands. Each hand produces a force of 40 Newton. Each hand produces a force of 40 Newton. And the book starts to slide down. The book slowly starts to slide down. Then the question is, find the coefficient of friction. So how can we do this? So we know the friction is this 20 Newton. So the force, or the force which is pulling the body down, the force which is pulling the body down is 20, and the normal is, or the, you can say, the extra excess force applied is 40 over here and 40 over here. So 40 plus 40, which is 80 Newton. So we know the force, which is 20, and the normal as 80. So can we find mu over here? So 20 is equal to mu into 80. So mu is equal to 20 by 80, which is 1 by 4, or 0.25. So we got the value of mu as 0.25. And there is no unit of mu because it's the coefficient of friction, it is itself a unit. Now let's see what is the angle of friction. sometimes when a force is not applied over here or over here and a force is applied over here, then there is some angle of friction. So the angle of friction is with the normal force. So angle of friction is denoted by lambda. Okay, angle of friction is denoted by lambda, and the angle of friction is tan inverse mu. That means lambda or angle of friction is 1 by tan mu into mu. So let's see a question. If the angle of friction is 45 degrees, so we know the value of lambda is 45 degrees, then find the coefficient of friction. The question is as follows. So we can substitute the values in this equation. 45 degrees is equal to 1 by tan mu. That means I'm going to put tan upwards and it's going to be tan 45 degrees is equal to mu, and the value of tan 45 is 1. The trigonometric ratios, you might have learned them, and the value of tan 45 is 1. So the value of mu came as 1. Simple. So I hope you might have understood all the concepts today we learned about friction, and I'm going to upload a part 2 of this because there's many more things on friction that we are left with understanding. So don't forget to watch the part 2, which will be going to be uploading soon. So thanks for watching, guys. Thanks for tuning into today's video. You are watching Zip Zap Academy, signing off.